worse, right? What's another good norm?
Like give them like feedback that's like time instead of like, oh, I think you should just change this because it's convicting.
I see. Did everybody hear Henry? Caleb, did you hear Henry?
Yes.
Okay. Thank you, Henry. Have you figured out how I look at your work? Like, do you know like what I'm usually interested in when you come and do your work? Like, do you have a sense of like what I think about your work? Because that might be a good place to start. Natalia?
How do you figure out the answer?
How did you figure out the answer? Yes, AJ?
Not the answer, but technically
Yeah, not the answer. What do I usually say to you?
Wait, D.
The answer, I think, how you figure it.
Yeah, like how you're thinking about the problem. And so I want you to be really, yes, Caleb.
What was your question that you just asked?
Like, what have you noticed about the way I look at your work and what I'm interested in?
process.
Yes.
Like, you look at our work. Wait, can you repeat the question?
My question is, what have you noticed, what have you observed about the way I look at your work?
You don't really care if it's wrong or right sometimes.
Yeah. What do I care about, Caleb? Do you have a sense of what I care about?
If you try.
Yeah, if you tried. If you showed your work, thank you. Amelia?
I think you look at like how you figured out what strategy you use.
Yeah. I am really, really fascinated because there are roughly, not counting the adults, but there are roughly 22 different kinds of brains in this room. And I always learn from each different kind of brain. Okay? Including you, Giselle. You have a very different brain than anyone else in this room. And I'm always curious. Yeah, I know you're paying attention to me. I can tell by your body and your eyes. No, that includes you. That I have 22 students in math, and each of you has a totally different brain and different way of thinking. So I'm always, when I look at your work, I'm always like, what was so-and-so thinking when they were experiencing these numbers, right? I'm not interested in whether you got it right or wrong. I'm interested in like how you think about numbers changing and how you're comparing numbers and so on. Yeah, AJ?
I care about the process, not the person.
Yes, I care about the process. Right? So I want you to do the same for me. When I give you someone's work, we'll walk through the problem in two different ways. And I want you to think about someone else's process. I want you to sort of take your brain off and try to put on the brain of that person and say, what was so-and-so thinking when dealing with these numbers? What strategies and what thought processes were happening? Okay? And then we'll try to look at ways in which people have been puzzling about comparing fractions. Could somebody say what was the task, the kind of mini pop quiz task that we did yesterday? What was the goal of that? Yes?
It proves that your skills about the benchmark and the fractions. I forgot the
Excellent. That's a general sort of perspective of what we had to do yesterday. Which strategy did you find useful and effective? What was it?
I was gonna say that like point of it is to find one strategy which we were when you give us the unit quiz, you
Exactly, right? So really good. And then the very concrete thing was, exactly. Finding which one is the biggest fraction and organizing fractions from the smallest fraction to the biggest. Okay? So I'm just going to take a second and write the fractions that we gave each other, and then we tried to sort of figure out how to use the two different strategies to organize them. Okay? Okay, so the four fractions we had were 5 parts of 9, 2 parts of 7, 1 part of 8, and 5 parts of 14. Right? And we're already notice that because of the denominators, the numbers